Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 30th, 2025, just about 3 days ago. It introduces a diffusion-based reasoning framework that outperforms GPT-5 by about 314% and Gemini 3 Flash by roughly 112% on complex vision-centric tasks. The paper is titled DiffThinker, towards generative multimodal reasoning with diffusion models. And as we'll see later, the move from text-based reasoning to image generation offers some really impressive gains in spatial precision. And for those interested in the implementation, the authors have shared their code on GitHub. You can find the DiffThinker weights on Hugging Face right now. They also included helpful Python scripts and bash commands to jumpstart your own inference and evaluation. So Figure 1 details the performance landscape across 7 reasoning tasks. On the left, the radar chart compares DiffThinker, shown in the solid purple area, against baselines like GPT-5 and Gemini 3 Flash. It consistently covers more ground, indicating superior results. Then, the visualizations to the right illustrate the method's advantage. In the central grid pathfinding example, the red line shows DiffThinker's precise visual solution, which avoids the errors seen in the text-based outputs of the other models. Well, to understand where those gains come from, Figure 2 contrasts the different reasoning paradigms. In the top left, Panel A shows standard models, which try to map visual inputs directly to symbolic text answers, using internal chain of thought. Next to it, in Panel B, we see thinking with image models, that iteratively call external tools, but still rely fundamentally on text-based processing steps. The real shift happens in Panel C at the bottom. Here, DiffThinker reformulates reasoning as a generative image-to-image task, where a diffusion transformer creates a visual solution, like drawing the red path, which is then parsed into the final output. Alright, Table 1 provides the hard evidence backing up that conceptual shift, listing results across 4 domains from planning to spatial configuration. Looking at the top section for closed-source MLLMs, even powerful models like Gemini 3 Flash and GPT-5 struggle, with GPT-5 averaging only about 21%. In contrast, the bottom section shows DiffThinker dominating the field. It achieves an average score over 88%, maintaining near-perfect accuracy on hard tasks like the 32-step maze, where other models often score 0. So, while the previous table highlighted performance gains, Figure 5 demonstrates that these do not require massive compute. The left panel, labeled A, compares training durations in hours. DiffThinker, represented by the yellow bar using flow matching, requires only 3 hours of training. That is comparable to standard supervised fine-tuning, but drastically faster than the reinforcement learning baseline, GRPO, shown in red, which demands 23 hours for the larger model. Shifting to Panel B on the right, we see the inference latency in seconds. Here, DiffThinker achieves a speed of 1.1 seconds per instance, making it faster than most setups for the QN3VL32B model. Okay, now Figure 4 visualizes a key property, native parallel reasoning. Instead of thinking sequentially, look at Step 1. You see multiple ghostly red paths appearing simultaneously, which means the model explores several routes at once. As we move to Step 4 and Step 7, it automatically prunes the invalid options. Finally, the output panel reveals the single optimal trajectory, showing how the diffusion process naturally converges from multiple hypotheses to the correct solution. Moving on to Figure 6, the authors show how DiffThinker can work as a collaborative partner. Panel A outlines the pipeline. DiffThinker generates multiple visual candidates, labeled 1 through n, which the large language model then verifies to pick the best one. Panel B charts the results on the Jigsaw Level 4 task. While Gemini 3 Flash scores 0% alone, and DiffThinker hits 80%, their collaboration jumps to 84% with just 3 candidates, proving the value of this hybrid approach. Wrapping up, 2 main takeaways stand out. Shifting reasoning from symbolic text to visual generation dramatically improves performance on complex spatial tasks, and it does so with surprising efficiency. The broader implication is that diffusion models offer a powerful new path for intelligent agents that struggle with text-centric logic. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.